Hi everyone, and welcome to our next video on vectors. If you remember from our previous video from the Khan Academy, we looked at the difference between scalars and vectors. And we had an example of our brick moving this way. And the scalar, which was simply the quantity, was 5 meters, and the vector was 5 meters to the right. And the scalar we call distance, or d, and for the vector 5 meters to the right we call that displacement, and we usually use the symbol s for displacement, and we have a little arrow on top to tell us that it's a vector. Now imagine that we picked up our brick again and we moved it over here, and that is 7 meters from the previous location. So now we've moved it a total of 12 meters to the right. And let's call this vector A, and we'll call this vector B. And what we've actually done here is we've added these two vectors together. So we can see that A plus B, and we'll call this our new vector C. That gives us 5 meters to the right plus 7 meters to the right is equal to 12 meters to the right. And this is very similar to how we add numbers together on a number line. If you have your number line here with 0 in the middle, and you have positive numbers on this side and negative numbers on this side, if you wanted to add two numbers together, say 4, 5, 6, if you wanted to add two numbers together, you'd just start at the first number, starting from 1, say, and if you wanted to add 2, you would go 1, 2, and end up at 3. And that's pretty much all we've done here, and that's because these vectors are one-dimensional vectors, and they behave a lot like numbers on a number line. So now we're going to look at what happens when we go to two-dimensional vectors. We're going to learn how to add and subtract those vectors and see what else we can do with them. Now let's look at 2D or two-dimensional vectors. So imagine you get on your bus at your bus stop, and the bus goes 3 kilometers east, and then it turns and goes 4 kilometers north, and that's where you get off the bus. And what you need to find out is, what is your displacement vector at the end of that bus trip? Now the way to do this that you need to learn is to do it graphically. So you would actually get out your ruler and draw a line using a scale. A good scale would be 1 centimeter per kilometer, and you draw a line 3 centimeters long this way and then 4 centimeters long this way, and you would then get your ruler and measure this. By the way, we call this the result vector, or the resultant. That's a word you need to know, the resultant vector. And when you measure the resultant vector with your ruler, you find out that the size is 5 kilometers, and the angle here, the angle is about 53.1 degrees. And when we define this angle, we always define it with respect to the x direction, the x-axis. Remember, with one-dimensional vectors we were looking at the number line, and with two-dimensional vectors you imagine them lying in the number plane, the xy axis that you should all be familiar with. So if we have a vector lying in our plane like this, then you imagine, if you draw a line there in the direction of the x-axis, this is the angle of the vector. It's also called the argument. So the two parts of a vector that we know are the size and direction. These are also called the magnitude and the argument. But for now, we'll just call it the angle. So now we've got everything we need to define our vector r, and your final displacement vector is 5 kilometers at an angle of about 53.1 degrees. And as I said, because you're measuring this with your ruler and your protractor, that's about as accurate as you can be. Now remember, this is just a simple example of a bus travelling along some streets, but it teaches us something very important, and that is how to add vectors in 2 dimensions. And you can see here we started at the tail of one vector, and we went to its head, and then we went to the tail of the next vector, and put it on the head of the first vector, and we went up to the head of the second vector. So all we've done really is we've laid our 2 vectors head to tail, head to tail. And when you add them together, you go from the very first tail to the very last head. And that gives you your resultant. So now let's look at that in a bit more detail. Let's continue this example to see how we would add multiple vectors together this way. So imagine you're on your bus again, and your bus starts off going 3 kilometers east, and then 5 kilometers north, takes a little turn, does 1.5 kilometers west, then goes 2 kilometers north, and then it goes, then it goes 6 to the east, then 4 south, and then 2 west, and then a big long street here, it goes 8 north, and then it goes 5 east, and that's where you get off the bus. Now this looks like a very complex path, and it might seem a bit difficult to find your final displacement vector. Remember, that's what it is we're trying to find. Your final displacement vector r, the resultant. And again, all we need to do is solve that graphically, and the way we do that is we go from the very first tail, follow our path all the way up to the very last head, and we get our ruler, put our ruler here, bring it up to the end there, and we measure this line all the way down, and that is our displacement vector r. And you can see all we've done is we've gone from the very first tail to the very last head. And if you were to draw all those on your paper again with your ruler to your scale, then in the end you would work out that the magnitude of r, which we write this way, you would measure that to be about 15.2 kilometers. And when you got your protractor, remember, when you're using your protractor to measure the angle, you always measure it with respect to the x-axis here. So your angle you would measure to be about 46 1/3 degrees to the x-axis. And that's about as accurate as you could be with your ruler and your protractor. So, remember, this is what we call solving graphically, and it's something you're going to have to know how to do, and you go from the first tail to the last head. And that's all there is to it, really. Now so far we've only looked at simple vectors at 90 degrees to each other because of our bus analogy. So now let's have a look at what happens when we have vectors that can be at any angle.